In this video, we're going to look at basic factoring, removing the GCF from polynomials. Here's our first example. Suppose I have the polynomial expression 80 minus 10y. The GCF, or greatest common factor, is 10, because 10 divides evenly into both 80 and negative 10y. In fact, 10 is the greatest factor that will divide evenly into both, hence the term greatest common factor, or GCF. So what we'll do is we'll pull a 10 out of the polynomial, which leaves us with 8 minus y. And that's it. We're finished with number 1. We've factored this as much as possible, and we're left with 10 times 8 minus y. Let's look at another example that's a bit more involved. Suppose we have 5a squared b to the 4th plus 15ab minus 30a. It might not be obvious what the GCF is just by looking at it. If you're not sure, you can break each term down into a product of its primes. For example, 5a squared b to the 4th can be broken down as 5 times a times b, which will be multiplied by itself 4 times, plus, and 15ab can be broken down into 3 times 5 times a times b, minus, and the 30 written as a product of primes is 2 times 3 times 5, and then times a. Now what we have to do is strike out the factors that are common to each term. I see that 5 is common to all 3. I see that a is common to all 3. How about another a? Well, it appears in the first term, but we have no more a's in the second term or the third. When I look at the b's, I see that I have 4 b's, or b to the 4th, in my first term, b in my second term, but no b's in the third. Therefore, my GCF is simply 5a. So I'll divide, or factor, 5a out of my equation, my polynomial expression rather, and I'm left with a b to the 4th plus 3b minus 6. So now we found the greatest common factor for each of our polynomials, simplified them, and we're finished. I hope you've enjoyed the video.